Well, everyone, welcome to Data Debug. So excited y'all showed up on our first Thursday that we have tried. Today we have two speakers that have both been to Data Debug before, which is like, I love every speaker that's ever spoken, but when you can convert somebody who shows up into speaking, that's just like a special, little warm fuzzy. So without further ado, I'm gonna get into it. Because we are a smaller group today, we'll have more time for discussion. I won't tell them to interrupt for questions. But yeah, so we can really get deep dives.
Thank you very much. Well, thank you everyone for being here. My name is Redwan Hussain. I'm a data engineer. This is a presentation on a little passion project that I put together for building a corpus for AI systems, specifically within the manufacturing space. So a little introduction on myself. I've been working with data for a little over a decade now, but my background is a little unique in that I actually didn't start off as a software engineer. I worked as an electrical engineer for utility companies, so started off as a field engineer, replacing transformers and doing construction type work. And then I pivoted over into being a program manager and started up New York City's first EV charging program for utility. And to do that, we needed a lot of data, and that's what kind of got me into this analytics journey. So did that for a few years, switched into manufacturing where I was a solution consultant, and that's where I sold software, did a lot of proof of concepts, actually walked inside factories and hooked into customers' machines and stuff, and just showed them what analytics can do for them. And now I currently work as a data engineer at United Airlines for our cybersecurity department. What I'll be presenting to you has absolutely nothing to do with what I do on my day job. So the motivation for this is when I was in manufacturing, a lot of my frustrations with AI stem from the fact that generic models are just not equipped to really help with manufacturing use cases. Like, a lot of models are not trained on things like PLC ladder logic, OPC-UA, stuff that's very specific and niche to the industry. And part of that is because manufacturing environments tend to be very airtight in that they don't allow cloud-based softwares to touch their systems. A lot of them also work on legacy software, so they may not be compatible with like all the new cutting edge stuff that's released. And the existing data that they may have may not necessarily be in the right format for AI or machine learning. You might have documents dating back to like the 80s or even the 60s. A lot of their information might be on clipboards that you might have to like physically get through. And I'm sure as data professionals, you'll understand that noise in equals noise out. And there are companies in the ecosystem, like you might recognize names like Schneider, Siemens, what have you. They might be working with their version of what AI is, but they're kind of in a black box and they're sold as like data scientists in a black box. So there's really no transparent like evaluations. So part of the motivation was to kind of build my own system, see if I can get something working, and also just understand the ins and outs of what it takes to evaluate like a system that actually works and has good data. And so this is a high level architecture of how my pipeline works. I have a discovery layer that's deterministic, and it looks through the web for various sources. So, started ingesting white papers, podcasts, scrubbing, various websites that were related to manufacturing. And then I have the ETL, which has a gating process, and it basically asks, okay, we found these candidates for download. Now, is it worth downloading? And once I've downloaded it, I'm going to take a look at the text and see if it's worth further analysis or if it's complete junk. And so it goes through that process. And then I also have an LLM extract, which I actually won't elaborate too much on at this stage of my project. This is an ongoing project, and I'll talk a little bit more about that later on. And so the intent was to extract certain signals from the data that I'm ingesting. Google has this really cool tool that's supposed to create like entity relationships based off of just like seeing data for the first time, and it's supposed to help with retrieval. And then once the data is validated, cleaned out, it gets segmented into chunks, and then it's stored into a relational database, as well as a vector database. And then at the end of the system, I perform some search operations to see if anything works or how well it works. So now, while building this, there are a few key design decisions that I made. So I mentioned that there was a gating process. So because I'm starting from zero and I literally have like no data to go off of, I can't implement a classification model of any sort. So the two gates that determine whether the data source is good enough for download are LLM based. The idea is to eventually gather enough data, and once I do enough analysis on it, to move into more of a deterministic system. That's a discussion for later on. Another decision that I need to make was how to chunk the data that I'm extracting out. So, am I gonna test 600 charts versus 1,000? So there was some analysis that was done there. And then for the embedding and the retrieval stack, I tested three different methods, and elaborate on that later. And then also for the storage, I quite frankly I don't want to pay for any cloud services, and I don't want to pay for. I wanted to reduce my costs, so I actually bought a Jetson Nano, like one of those NVIDIA kits. I have it running at home. It kind of operates as like a crude serverless, a headless server. So that is where the ingestion was taking place and a lot of the data cleaning was taking place as well. And that is also what serves as like the source of truth. Like all the main data is stored on the Jetson. Then I use my MacBook, the client, for all analyses. All right, so now when evaluating my project, I want to know, is a corpus healthy and are the chunks coherent? So as I'm querying or as I'm submitting various queries, are the right documents being identified to produce an answer? So at this point in time, I'm not doing the end-to-end RAG yet. I'm not evaluating if like the generated answer makes sense. I'm just trying to see if the data that is being identified is if the data is being identified to generate that answer, if that makes sense. And so to evaluate this, there was a set of queries that I created. Most of these were created by myself. And so these are all domain-specific questions that were generated. So this is something that like only someone that worked in manufacturing could come up with. And I try to come up with about 30 questions that range from what a controls engineer might ask, what a plant operator might ask, to like what a layperson might ask about manufacturing, specifically within industrial automation. And so for each query, I had an answer key, which consisted of the correct documents that would be able to provide the answer for the query. And so I did kind of like a Q&A type exercise where whenever I would submit a query, it would spit back the LLM or the AI system would spit back the list of documents in a ranked order that it thinks would be the correct, and then I did some comparisons. And so the specific evals that I implemented were MRR, mean reciprocal, forget what the full acronym stands for at this point, but essentially a measure of, of all the documents that you have listed, how far in are the correct ones? So like if you go back to, this first question, and I have reference IDs 25, 264, and 1012, it looks for the first instance of any of these. And if it's further down the list, then its score would be on the lower side. So it ranges from 0 to 1, and so the higher the score means we found this document a lot more quickly. Does that make sense? It's like a pretty technical thing that I'm trying to explain at a high level. And the other evaluation metric was recall. So recall is of this total set of reference IDs, how many of them are being detected? So if there were 3 and only 2 of them were detected, then your recall score is 2 out of 3. And so I tested 3 different configurations. The first configuration is dense only, so that's pretty much looking for a cosine similarity. I ask a question, the AI system looks through all my documents, and then it tries to find synonyms or semantic similarities between what I'm asking for and what might be in the documents, and it spits back, the list of reference documents. But that itself is not enough because this is a highly technical space where, different acronyms mean different things. So you don't just want context, you also want specific keywords. So then I did a hybrid approach of having keyword detection along with context, and then combining the result of those into a hybrid. So I did that. And then the third configuration was a progression of that where I say, okay, you know what, perform the hybrid approach of like the 1,000 documents that I have downloaded. I just want you to identify the top 50. And then for those top 50, you do a re-rank, which was done by cross-encoding. Don't have too much time to get into that right now, but cross-encoding is just kind of like, imagine, well, now I am explaining it. So imagine two people studying something and then trying to compare notes. That's called bi-encoding. And then cross-encoding is like one person looking at two sets of notes at the same time, which takes a little longer. So there are some trade-offs when it comes to speed, stuff like that, but it's supposed to be more accurate. So I evaluated the 31 queries that I created, and it turned out that the third approach performed the best. However, the evaluation is still not complete because I still need help from other domain experts to pitch in. They might ask questions and think about the answers in a different context than I do, so they might also have different reference IDs. And I also need to add more trick questions. So, asking questions to which I know there is no answer to make sure that the system can identify the coverage gap and therefore not hallucinate. Does that make sense? All right. So based on the results, a few things that I learned about my system that I created so far. The gating process was working. So about 40% of the corpus is actually dead weight. So they were rejected for various reasons. For example, a certain website might have manufacturing keywords, but once it was downloaded and the HTML was scrubbed, most of it was like boilerplate stuff like navigation or just like things that won't really add any value to the corpus. Ranking quality is still the bottleneck, so I still need to perform more of a rigid evaluation with, collaborating with other domain experts. And the domain quality gates didn't catch everything. So I also realized that there were if you recall back to the LLM extract phase that I have in my pipeline, there are certain documents that were downloaded and passed the gating, but once they passed through like that little adapter, zero signals were produced. Like the tool wasn't able to find any kind of like relationships about manufacturing within those. So that shows that there might be other gaps that my system's not catching. So a lot more data science work has to be done. So moving forward, I need to expand the query set. I need to look into context-specific tuning. So maybe there might be certain PDFs that might be producing better answers. But if I look into audio sources, I might not be able to retrieve those for certain types of queries. I'm going to build out the rest of the RAG system, so have like actual agents that are designed to handle different types of queries, or maybe look into different types of corpuses and classify them a little better, and also do more rigid evaluation on the end-to-end system. So not only am I picking up on the right documents, but are the answers that are being generated actually helpful? So that was just a quick summary of the project that I've been working on for the past few months. It's something that I'm continuing to build out. And so if you're interested in just like either manufacturing or try to build like your own domain-specific corpus, I've been publishing a lot of my work on GitHub. I'll eventually put README so that if you want to shift it to like a domain that you're interested in, like let's say life sciences, which is also like very rigid about who they allow into their system, I'll have instructions on how to adapt it to your needs. So, and also please feel free to connect with me on LinkedIn. So thank you very much.